removal of electrons is called as oxidation. Plus A plus is formed, or generally let us assume it is forming A plus. We are using a reagent. Okay, we are using a reagent. This reagent, what is this reagent going to do? It is going to absorb this electron. Then means it should be reduced. It should be reduced. Okay, therefore the reduction potential of these oxidizing agents are generally higher than the organic compounds. The reduction potential of these oxidizing agents is generally that is more than the organic compounds. That is why they are getting reduced when they are combined with these organic compounds. Okay, that's why we are using mostly this inorganic reagents are used as oxidizing agents. Okay, am I correct, Anna? Ramesh, that's it is the first point which I want to discuss today. Why these inorganic compounds are used as oxidizing agents? Okay. Okay. Anyhow, let us move further. Can you hear me? Hello, students.
Yes, sir.
Yes, sir.
Then that is what is the thing we had learned is oxidizing agent should get reduced. Whereas if you use a reducing agent
Oxidized.
should get oxidized. Okay, that minimum knowledge we must at least try to understand that concept. Okay, let us see the oxidation of non-functional carbon compounds. That is, there is no specific functional group in them. Okay, there is no specific functional group in them. Then how are they going to get oxidized? Okay, for example, we know that there are a number of compounds which contain a methyl group. Okay, that is how do you know that there is a methyl group? These methyl groups, how many methyl groups are there? Or for example, we are having a compound like this, where methyl cyclohexene or toluene is there at least. These methyl groups are also, that is, oxidized. These specific methyl groups are oxidized by using a method called as estimation of the CCH3 can be done by using reagents like KMNO4 chromic acid. Okay, there are chlorine attack in the presence of this on alkanes in the presence of chromic acid. Okay, that is, all these reagents are used for Kuhn-Roth estimation of methyl groups are done. Okay, estimation of methyl groups is done by using these reagents. They are oxidizing agents, potassium permanganate, like that. Okay, what is done here? Okay, I had taken all the screenshots from Morrison Boyd itself. Why? Because it is not possible for us to draw all this. Here, for example, if you take this compound, that is methyl is there is a methyl group. This methyl group, we can estimate that how many methyl groups are there in this one? Only one. By using chromium trioxide, CrO3 is used. Okay, which is converted into acetic acid. CH3COOH is formed in the presence of this chromium trioxide. Okay, that is the number, whatever the number. If there is only one mole of acetic acid is formed. If there are two methyl groups, 2 moles of acetic acid is formed. Therefore, we can estimate the number of methyl groups in these compounds.
Sir,
okay,
ethyl group.
The method of what is the reaction mechanism involved in this one? Is a free radical, or even there are two paths, concerted path is there or free radical. There are two assumptions which both are okay. Free radical mechanism is there, where chromium plus 6 is converted into chromium plus 3. It is plus 6, it is converted into plus 3 here. So plus 6 is converted into plus 5 first of all by forming a free radical. Therefore, it is called as free radical path. And later on, again, one more electron is also removed and finally hydrolyzed to form oxidized product. Okay, my dear students, you must learn how to estimate the methyl group, CrO3. Okay, ఇట్లా రియేజెంట్ మెకానిజం అడిగారు కాబట్టి ఏం చేయాలంటే మనము రియాక్టెంట్ ఏంటిది ఒక టేబుల్, ఈ క్లాస్ అయిపోయిన తర్వాత ఈ పీపీటీ చూసైనా క్లాస్ చూసైనా ఒక టేబుల్ తయారు చేయాలి. రియేజెంట్ ఏంటిది, వాట్ ఈస్ రియాక్టెంట్ ఏంటిది, ప్రొడక్ట్ ఏంటిది, ఏం చేంజెస్ అంతే. అది గమనిస్తే మీరు యూ కెన్ ఈజీలీ గెట్ ఇట్ టు దిస్ ఆక్సిడైజింగ్ and oxidation and reduction. Then constructed path is also there, where it is forming a chromate ester is formed. Chromate ester is formed here. Okay, CrOH, OH. Okay, therefore it is an ester. Okay, chromic acid, H2CrO3. Okay, H2CrO4 is nothing but chromic acid. CrO3 plus H2O. Okay, or potassium dichromate plus any acid gives chromic acid. Potassium permanganate or potassium dichromate plus any acid, H2SO4 or sulfuric acid, we generally get chromic acid. In our lab also, మన ల్యాబ్లలో కూడా apparatus కడగడానికి chromic acid వాడతాం. Okay, these hydrogens are converted into this OH group by means of this ester. Okay, chromate ester is there. Then that is about Kuhn-Roth estimation of this methyl groups. Then let us see another one. First of all, we had seen that KMnO4, we can use KMnO4 also, or we can use chromic acid or chlorine by boiling with chlorine, for that is chromic acid followed by chlorine, that converts this methyl group into acetic acid. Okay, next, second reagent is selenium dioxide. Okay, selenium dioxide or dibutyl chromate, both are having same mechanism, is required for, what is required is C double bond C is required for this, that is allylic CH bond is. Okay, what is allylic CH bond? Okay, we can write like this. There should be an allylic bond, must be there. This allylic hydrogen, allylic carbon is getting oxidized here.
Sir.
Hello.
Sir, 1 minute, sir. Chinni is unmute, please. Mute, please.
Huh?
Disable setting, sir.
Okay, no, okay, right. I got it. Okay, ikkada allyl group, this is called as allyl chloride. We know this is called as allyl. Okay, CH2 is there here, and CH is there. It is CH2, it is CH, it is CH2, Cl. It is called as allyl chloride. This carbon, this compound, this part is getting oxidized here by means of, by using selenium dioxide. What is going to be formed? Okay, it is going to form this alpha beta unsaturated product is formed here. Okay, selenyl regioselective is not, but also stereoselective. Both are involved here. Okay, what is the purpose of this one? Allyl chloride for even benzyl also. If it is like the cyclohexyl, it is there. Therefore, where will be the product formed? If you use SeO2, selenium dioxide, the product formed or oxidation will take place at the allylic position. Okay, at the allylic position only the oxidation will take place. Okay, that is most important, my dear students. Okay, here the oxidation is taking place at this position. Okay, that is selenium dioxide or dibutyl chromate is about the selenium dioxide. Allylic oxidation takes place. Allylic CH bond of alkenes is regioselectively oxidized. What is meant by regioselective? Regioselective means here the oxidation is taking place at that particular region only. Which region I am talking about? The region where it is neighboring double bond is there. That region only is attacked, and it is also stereoselective. Why it is called as stereoselective? Because if there is a branching, selenium dioxide will enter or will attack only from the less hindered side. That is why it is said to be the stereoselective as well as regioselective reagent. Okay, that is here. If you take up this compound, diketone is formed here. Okay, diketones are formed. How is this possible? Because here this ketone will undergo keto-enol tautomerism. There will be a double bond here, or else any double bond is there here already existing. Therefore, it easily undergoes. Okay, there is a double bond here. Then what is the condition for us? Condition is there should be a allylic. Okay, this is nothing but like that only, almost like allylic carbon. Okay, this carbon, this hydrogen is removed now, and it is converted into this, that is double bond O is formed here. Okay, that is, it is undergoing ketoenol tautomerism. See here, it is undergoing ketoenol tautomerism. That is, OH is there, and it is forming like this, a compound like this, and it is, okay, this carbon is getting oxidized to form diketones. Okay, diketones are formed. I think you got some idea about selenium dioxide. Selenium dioxide is useful for allylic oxidation of CH bond. Okay, that is about selenium dioxide reagent. What is the use of selenium dioxide? We can use it for oxidizing the allylic CH bond. It is regioselective as well as stereoselective also. Then the third reagent which we are going to learn is about mercuric acetate. Yesterday we had seen about mercuric acetate also. Allylic and benzylic CH are converted into COH groups. What is meant by oxidation in this organic chemistry? Alkanes are converted into alkanes, alkenes are converted into alcohols. Okay, you are learning after alkanes, you are learning alcohol. Therefore, that is a second oxidized product. After alcohols, they are converted into aldehydes or ketones. Okay, they are converted into aldehydes or ketones. That is a third zone of oxidized product. Okay, third degree of oxidation. Aldehydes and ketone, that is carbonyl compounds, we can call it as ketones. Okay, then after that, they are converted into carboxylic acid. Carboxylic acids are the highest oxidized form of a carbon. Okay, they are converted into carboxylic acids, COOH. Okay, then if you further keep this carboxylic acid, they are converted into esters like that, depending on the availability of the alcohol. Anyhow, this is the, okay, here alkenes are converted into alcohol. Therefore, it is also nothing but alkenes are converted, alkenes are converted into alcohols, means it is oxidation. Okay, mercuric acetate is helpful for this oxidation. It is converting this bond. Again, allylic oxidation takes place. Even benzyl or benzylic CH. Okay, in benzene, the bond, that is CH bond, is there here. This is benzene, and we are having CH3 like this, CH3. These hydrogens are called as benzylic hydrogens. These hydrogens are converted into alcohols. CH bond is converted into OH, COH group. Okay, that is this. Why it is called as benzylic? Because we are having double bonds here. As we are having double bonds, okay, we are having double bonds like this. This is nothing but allylic carbon. Okay, to this double bond. Therefore, allylic CH bond is getting oxidized. I think you got some idea about this mercuric acetate, how it is going to function. Okay, mercuric acetate, as we had seen, it is converting all these compounds into allylic compounds. Okay, then C double bond C dilute alkanes. Okay, then in the presence of KMnO4, dilute KMnO4, cis per hydroxylation will take place. Okay, KMnO4 is used for the hydroxylation. Okay, alkaline KMnO4 is used for cis per hydroxylation. Trans per hydroxylation is carried by epoxidation with peracids followed by acid hydrolysis. Okay, let us see this one. Okay, potassium permanganate, alkaline potassium permanganate. In alkaline medium, it is going to form cis hydroxylation. We know this from, even we had learned even yesterday also while dealing about addition reactions, especially potassium permanganate is used, or even osmium tetroxide is used for cis hydroxylation. Okay, that is, it is forming a cyclic compound. A 5-membered ring is formed as a transition state. Cyclic manganate ester is formed. Okay, it is going to convert by the alkaline medium is there. Therefore, it is readily oxidized, hydrated, hydrolyzed to form 1,2-diol. 1,2-diol is formed here. In neutral medium also, it forms alpha ketones. Ketols are formed. Okay, that is ketone group is there adjacent or to the neighboring carbon. Therefore, in neutral medium, it is giving alpha ketols or ketols, whereas in acid alkaline medium, it is giving meso 1,2-diol. Diol compounds are formed in alkaline medium. Okay, then cis, as I said, cis hydroxylation can be done even by using osmium tetroxide. Osmium tetroxide also can be used for cis hydroxylation. Okay, then here okay, that is here we are using osmium tetroxide. Again, a compound, a 5-membered ring is formed to form cis 1,2-diol. Cis 1,2-diol is there here. Okay, osmolysis, oxidation. Yesterday we had seen even this osmolysis also. Oxidation with bulky bis pyridine complex of osmium tetroxide. It is regioselective and stereoselective. Why it is regioselective? Because it is going to attack only on the cis side. Okay, and stereoselective. It is attacking cis side. Therefore, it is called as regio on less hindered side of the double bond to give cis diols. What is the use of this NMO? Last classes we had seen about N oxide of morpholin, which regenerates osmium tetroxide. Okay, osmium tetroxide can be easily regenerated. Therefore, okay, that is in this way it is regenerated. Osmium trioxide is formed, tetroxide is converted into trioxide. This trioxide is converted again into osmium tetroxide. NME, N-morpholin oxide. NMO, N oxide of morpholin is called as NMO, N oxide of morpholin. Okay, this is about osmium tetroxide. I think this is also one of the reagent. Even alkaline KMnO4 is one of the reagent. Neutral medium, it is going to give alpha hydroxy ketones are formed. Trans per hydroxylation, it is also called as Prevast oxidation. Okay, here iodine is used in I2, reacting with I2 iodine with the silver carboxylate in dry aprotic solvents. In iodine, okay, for trans hydroxylation, we are using KMnO4 osmium tetroxide for that is cis hydroxylation. For trans hydroxylation, we have to use silver acetate. Okay, silver carboxylate. Okay, silver ester of this carboxylic acid and iodine. Okay, what is going to form same as that of cyclobromonium ion? Cycloiodonium ion is formed, and the attack of this silver ester is going to take place, and the ring opening followed by another mole of attack of this silver acetate, and ring opening takes place. We have by the formation of 5-membered transition state, this is going to take place, and anti-addition finally it is giving, that is trans diol. It is called as Prevast oxidation. My dear student, this is also very important even for CSI or higher exams also. Prevast oxidation, how cis hydroxylation takes place by for alkenes. Okay, this is about different types of reactions we had seen. Here also just now we had seen about potassium permanganate. This potassium permanganate is converting this first carbon of this benzene to COH. Whatever the length of the chain may be, whatever the length of the chain, it is the first carbon is getting oxidized. Complete oxidation of the side chain takes place. Okay, complete oxidation of the side chain takes place to, okay, for what we have to do is how to get rid of this side chain. Okay, how to get it is called as Ethard reaction. Chromyl chloride is used. CrO2, Cl2 in CS2. Actually, Okay, what is done is it is completely whatever the chain may be, whatever that is ethyl benzene, propyl benzene, or branched benzene is converted into benzoic acid in the presence of KMNO4. But what are we doing is we want to make only this carbon get oxidized into the ketone and the remaining chain should be intact. It should not be removed. For that sake, what are we doing is CrO2Cl2, chromyl chloride in carbon disulfide is used. Here, the complete oxidation of the side chain is not taking place. This reaction is called as the Ethard reaction. Okay, it is precipitated and this adduct that is separated and it is hydrolyzed to give this one. This is also very important reaction. Why? Because we are selecting, we are not making the complete oxidation to be done, and we are making so that the oxidation so that only the first carbon bonded to the benzene is getting oxidized rather than a complete chain. Okay, this is called as Ethard reaction. Very, very important reaction, my dear students, about chromyl chloride and carbon disulfide. Okay, you must know the difference between the reagents. What is their function? Which carbon is getting attacked? Okay, the sharpless epoxidation also is a cis epoxidation. Okay, in higher studies we will learn about symmetric sharpless epoxidation also. Prevast oxidation is for trans hydroxylation. Then another one is peracid, that is peroxy acid epoxidation of C double bond C. We have seen this one. That is same as, it is almost the same as sharpless epoxidation. Epoxide is formed with peracid, peroxy, carboxylic acid. And here it is stereoselective. It is attacked from the less hindered side. What could be the reason? Because it is a bulky acid. It itself is a big macromolecule. Therefore, it will attack only on the less hindered side. Then monohydroxylation of C double bond C can be done by hydroboration reaction. Okay, diborane is attacked. As we had seen, diborane is a, what is it going to give? It is going to give the anti-Markovnikov product. Okay, B2H6, BH2 is there, and hydrogen is also there. Where will this hydrogen will go? That is to the carbon which is H minus. Okay, therefore it should, according to Markovnikov's rule, the hydrogen should attack at this end. But now it is attacking at which end? At the other end, it is attacking. It is attacking at this end, and BH2 is attacking at this end. It is against the Markovnikov's rule. Okay, wherever the boranes are involved for addition reactions, Markovnikov's rule is not valid. It is called as, that is opposite to that Markovnikov's rule takes place, known as Kharash effect. Trialkyl boranes on oxidation with hydrogen peroxide will undergo oxidative rearrangement to form alcohols. Okay, we can easily convert this trialkyl borane. Why? Because there are 3 hydrogens to the boron trihydrate is having 3 hydrogens. All the 3 hydrogens are getting substituted by this alkyl group. We are using this alkyl group that is having 3 carbons. Okay, therefore 3 moles of this one are getting substituted onto this boron. And finally, on that is by using H2O2, we can convert them into this alcohols. They are converted to alcohols. Okay, what is done here? What is the product here? I think you had understood. Okay, here we are taking methyl and ethyl group is there, Me is there, that is methyl group. Here we are having ethyl group, C2H5 is there on this side, C2H5. Slowly let us learn, let us try to understand. And after that, we are having double bond. Okay, we are using methyl group here. Methyl group, and it is CH2. There are 2 hydrogens are there. Okay, according to the Markovnikov's rule, rich becomes richer. This carbon is rich of hydrogens, it should become richer. But here, as I said, Diborane is against this one. Therefore, BH2 is going to attack. Okay, instead of hydrogen, BH2, which in turn is converted into OH group. And this carbon is having H. BH2 is first ikkada attack aitadi. Tarvata itla form aitindi. Ante idi against Markovnikov's rule. If you use Markovnikov's rule, what should be the product? Markovnikov's rule వాడితే ఏం ప్రొడక్ట్ వస్తుంది మనకు? ఇక్కడ OH రావాలి. You should get OH at this end. It is C2H5. Okay, that is why, because these are very important. Simple reagents are important. ఎప్పుడైనా గుర్తుంచుకోండి. ఇట్లా H అన్ని ఇక్కడ వస్తాయి. ఇది మార్కోనికఫ్స్ ప్రొడక్ట్ అయితే ఇదేమో యాంటీ మార్కోనికఫ్స్ ప్రొడక్ట్. ఎందుకంటే మనం వాడిది ఏంటిది? డైబోరేన్. Diborane is the reagent we are using. That's why it is giving anti-Markovnikov product. Okay, that is about monohydroxylation. We had seen dihydroxylation, monohydroxylation, transhydroxylation, cis-hydroxylation. Okay, all those we had seen. Then, how to convert C double bond C into ketone group? C double bond C, thallium nitrate is used. Thallium nitrate is used to convert this C double bond C into ketone. Okay, it is converted into ketone group by using thallium nitrate. Okay, regioselectivity is due to steric factor. Okay, that is ketonization. First of all, enol is formed. First enol form avutundi, tarvata enol tarvata manaku it undergoes automatic tautomerism to give ketone. Okay, that is here at this middle carbon that is bonded to the chain, long chain, is going to get this ketone group by removing this double bond also. ఇక్కడ OH వస్తుంది యాక్చువల్గా. OH తర్వాత ఈ కీటో ఇనాల్ టాటామెరిజం ద్వారా మనకు కన్వర్టింగ్ ఇంటూ కీటోన్ గ్రూప్. థాలియం నైట్రేట్ డైరెక్ట్గా డబుల్ బాండ్ను మార్చేయచ్చు. అంటే ఇట్లా ఉందనుకోండి, సైక్లోహెక్సీన్ ఉందనుకోండి, సైక్లోహెక్సిన్ కూడా ఈజీగా మనం కీటోన్ లాగా మార్చొచ్చు. ఒకసారి ఆలోచించండి ఎంత ఈజీ అయ్యింది. జస్ట్ డైరెక్ట్ హెక్సనోన్ is formed directly. Okay, we can convert this one into ketone directly by using thallium nitrate. Thallium nitrate is a reagent. Okay, that is enough, I think, about this one. Then hydroperoxidation of alkenes. Okay, OOH. We are learning about these peracids, peroxy acids. Okay, there is a reaction called as ene reaction where singlet oxygen is used. Okay, singlet oxygen is used in this reaction. By irradiation, it directly gives hydrogen peroxide, hydroperoxide derivative at the allylic position only. At the allylic position, it is going to give this one. This is the hydrogen. Okay, then the bond is shifted. At least one CH bond in the allylic position is the condition for this. Okay, if there is no hydrogen here, this reaction will not take place. This reaction is called as ene reaction. Ene reaction. This is about hydrogen hydroperoxidation. Okay, we are converting this instead of OH, we are converting into OH. How to get this OH on this side? Allylic hydroxylation can be done by that is we had seen number of reagents. Selenium dioxide is there. Okay, like that we had seen a number of reagents where allylic hydroxylation also can be done. Okay, the trans epoxidation. Before that we had seen especially mercuric acetate is used for allylic hydroxylation. Mercuric acetate. అయితే allylic దగ్గర ketone form అవుతుంది ఇక్కడ. That is hydroperoxide ఎట్లా వచ్చిందంటే by using this singlet oxygen. Oxidative cleavage. ఇప్పటి వరకు మనం OH కలుపుతున్నాం, డబుల్ బాండ్ ఏర్పరుస్తున్నాం, OOH చూసాం, ఇవన్నీ మనం నేర్చుకున్నాం. సెలీనియం డయాక్సైడ్, పొటాషియం పర్మాంగనేట్, థాలియం నైట్రేట్, Prevast oxidation, and chromyl chloride. CS2, all those are very, very important reactions. Let us see about how it is cleaved, how to cleave this C double bond C. Okay, ozonization, ozonolysis is one of the reaction that is used where 2+3 dipolar cycloaddition to an unstable malozonide. This intermediate quickly rearranges to give ozonide, and it is ring open takes place. Okay, definitely I will explain the model questions also after completing oxidation reduction. Just now I was talking to sir also regarding this. అన్ని బోర్డ్ పేపర్స్ అన్ని తీసుకొని నెమ్మదిగా ఒక్కొక్క క్వశ్చన్ చూద్దాం మన ఏరియాలో మనం డిస్కస్ చేసిన ఏరియాలో. Oxidation conditions with H2O2 to form carbonyl compounds as degradation compounds. Okay, the ozonide ring ను ఓపెన్ చేసాం అనుకోండి, H2O2 ద్వారా ఓపెన్ చేస్తే C double bond O compounds వస్తాయి. Reductive conditions, zinc acetic acid ద్వారా కూడా చేయొచ్చు. Okay, this is about this double bond. We had seen even this reaction earlier. Okay, ozonide, you are learning about this ozonolysis. Okay, ozonolysis takes place. It is a dipolar addition. It is giving a 5-membered ring, okay, which the ring is opened and finally it is completely cleaved, dissociated into two. That is, it is broken. Okay, this carbon is going to give one carbonyl group. This carbon is going to give another carbonyl group. Okay, we can use that is by using H2O2, we can convert them into this one, or even by using zinc acetic acid also we can convert. By using H2O2 also we can do this one, or by using zinc acetic acid also we can get this one. It is called a reductive oxidation. It is called as oxidative cleavage. It is called as reductive cleavage. Why? Because it is a reducing agent, zinc acetic acid. It is, this also is going to cleave them. Okay, reductive cleavage, another one is oxidative cleavage. That is about ozonolysis reaction. Okay, then alkyne triple bond to ketones. How this triple bond, C triple bond C are converted to ketones by hydration of triple bond with H2SO4 in the presence of HgSO4. Okay, this is also a very famous reaction where Markovnikov's rule. Okay, H2O. In H2O, we are having OH as well as OH minus is there. Another one is H plus. Where will be this in the product? OH minus should be added to the middle carbon according to which rule? According to the Markovnikov's rule. Therefore, what is formed here? Enol is formed, and which undergoes ketoenol tautomerism to give this ketone. Here, what is the use of this HgSO4? It is going to reduce the electron density on this one. This HgSO4 is going to bind with this triple bond so that the electron density is reduced. Okay, that is, it is pulling the electron density towards itself so that the nucleophile, entering nucleophile will not get repelled. That is about alkyne triple bond to ketones. Alkyl triple bond to ketones and aldehydes. How they are going to form aldehydes or ketones? Treating with borane and alkaline hydrogen peroxide. Okay, if you use borane, it is converted into OH. This OH can be converted into aldehydes. That's all. Terminal alkynes unte aldehydes వస్తాయి. అట్లా కాకుండా మధ్యలో ఇది CH, H బదులు R ఉందనుకోండి, they are going to give ketones. That's all. Okay, that is, ఇది terminal alkyne. Terminal alkyne hydroboration చేస్తే followed by H2O2 will give aldehydes. ఎందుకు చెప్పండి ఇక్కడ HOH. H is going to be there here, and it is anti-Markovnikov. Against the Markovnikov's rule, it is functioning. Therefore, it is giving H and OH on the adjacent carbons, and one of the pi bond is removed. That is like enol is formed. Enol undergoes tautomerism to give ketonization, to give this aldehyde. That is about alkyne triple bond, C triple bond C to ketones, and aldehydes are formed like this. Alkyne triple bond C triple bond C to acyloins. C double bond O CH is formed. Acyloin. It is called as acyloin. One C double bond O is there. Another one is CH is also formed by using thallium nitrate. Okay, just now also we had seen about this thallium nitrate. In alkenes, okay, in alkenes also we had seen about this thallium nitrate just now. Okay, thallium nitrate is used for forming OH in a double bond containing compound. OH, there is no chance for the, again, acyloins formation. Whereas in alkynes, what is going to happen is, okay, that is, it is forming, acyloins are formed. Okay, see, OH is there. Just now we had seen, if there is no double bond, it is removed and enol is getting undergoing tautomerism to give ketones. Okay, whereas here, acyloins, OH is there. It is going to be removed and converted into acyloin. OH, C double bond O పక్క పక్కకు ఉంటే దాన్ని అసైలోయిన్స్ అంటాం. థాలియం నైట్రేట్ గుర్తుంచుకోండి, డబుల్ బాండ్ ఉన్నట్టయితే ఒకటి వస్తుంది కీటోన్. అదే ట్రిపుల్ బాండ్ ఉన్నట్టయితే ట్రిపుల్ బాండ్ లో మనకు అసైలోయిన్స్ ఏర్పడతాయి ఇన్ అక్వేస్ యాసిడ్. Okay, why acid is required? Because for the removal of this thallium nitrate and followed by hydroxylation must take place. That's why we require acid. Diketones also can be formed. Okay, that is, this acyloin is converted in diol. Okay, then we know that because of tautomerism, it is undergoing enolization and diol is formed. This diol, in the presence of thallium nitrate, is giving vicinal diketone. Diketones are also formed with thallium nitrate whenever there is a scope for, that is, mesomerism. All double bonds are shifted easily. Okay, that is about CC, that is homopolar. C double bond C we had seen, CC bonds we had seen, C triple bond C also we had seen. Okay, for CC bonds, what we had seen is we can use especially Kuhn-Roth method, where chromic acid, potassium permanganate can be used for completely degrading, okay, or removing the carbons from the carbon chain. Oxidation of heteropolar functional groups. Pyridinium dichromate, PDC, DDQ, lead acetate. Okay, DCC, dicyclohexyl carbodiamide, oxalyl chloride. All these are good reagents, both 1,2 alcohols, but they are not going to completely, that is, react with C double bond C, CH what to react kav. Dento react aithe COH bond to react. Okay, gives good yield of CH RCHO, but are also formed. Pyridinium. Okay, alcohols, first alcohol చూస్తున్నాం. PDC వాడితే ఏమవుతుందంటే, PDC I think is there in since intermediate also we had learned in alcohols how to prepare aldehydes, but here byproducts are also formed. అందుకే దాని బదులు ఏం చేస్తున్నారంటే మనము DDQ, డైక్లోరో డైసయానో క్వినోన్, lead acetate in pyridine, ఈ రెండు ఫేమస్ రియేజెంట్. DDQ, డైక్లోరో డైసయానోక్వినోన్. Open air oxidation, all these are used. Allyl alcohol oxidation. Allyl alcohol, it is an allylic alcohol where manganese dioxide is, or DDQ, converts into aldehyde group. Okay, CH2OH is converted into aldehyde. Then manganese dioxide can be used, or DDQ also can be used. Alpha ketones are oxidized by cupric acetate. These are called as alpha ketones. Alpha ketoaldehyde is formed. Okay, that is, it is also in the same as that of allylic alcohol. They are converted into cupric acetate, they are converted into aldehydes. Okay, that is about allyl alcohol oxidation. Then tetra N propyl perruthenate. High sensitive ketoaldehyde are generally formed from primary alcohols. Primary alcohols are converted into aldehydes by using this reagent tetra N propyl perruthenate. Okay, this is a reagent. What is required is NMO, N-methyl marpholin oxide is required. What is the use of this one? We know that ruthenium is very costly reagent. Therefore, it can be again regenerated, reoxidized. We know that in the first part of this session itself, we have learned that the oxidizing agent is always reduced. This reduced oxidizing agent is further oxidized here. Perruthenate, tetra N propyl perruthenate is converted into ruthenium tetroxide in the presence of NMO. NMO is used here. N-methyl marpholin oxide. Yesterday also we had seen about this reagent. In osmolysis, osmium tetroxide lo kuda ide vaadtam. DMP reagent. Okay, the DMP, Des-Martin periodinane reagent, is used in chemoselective oxidation of primary and secondary alcohols. Okay, these are here is converted into aldehydes. Okay, this is the primary alcohol, where this is the reagent, DMP reagent. Okay, 1,1,1 diastoxy, 1,1 dihydro, 1,2 benzyl iodoxazole, 3 1HO. Okay, DMP reagent. Just ఇట్లా గుర్తుంచుకోండి, ఇది ఇంపార్టెంటా కాదా అనేది తర్వాత ఆలోచించండి. కానీ ఇక్కడ ఏమైతుందంటే అలైలిక్ ఆల్కహాల్ ఇస్ కన్వర్టెడ్ ఇంటూ ఆల్డిహైడ్. ఓకే, primary alcohol to carboxylic acid. How primary? Until now we had seen about the conversion of alcohol into that is aldehydes. We had seen primary alcohol directly converted into carboxylic acid. Sodium chloride, sodium hypochlorite, and 1-oxy tempo. It is called as tempo. 1-oxy 2,2,6,6 tetramethyl piperidine. Okay, are used directly to convert this CH2OH into COOH. Sodium chloride, hypochlorite, and tempo. All these three are used to directly convert this alcohol, primary alcohol, into carboxylic acid. Okay, this is very important reagent. Why? Because it is an important. Why? Because we are learning about this chromic acid. Jones reagent, CrO3 in ammonium sulfate. Okay, using acetone as 8NH2SO4. Using acetone as solvent, convert secondary alcohols into carbonyl compounds. Chromic acid, chromate ester is formed. This chromate ester, okay, what are they going to do is they are converted into chromic acid. Okay, then this chromic acid easily oxidizes the secondary alcohols into ketones. Chromate ester is formed. Okay, on hydrolysis of this chromate ester, it is going to form ketones are formed. Okay, the primary product formed. Okay, the product is not oxidized further. That is important ikkada. Endukante idi kuda oxidize aithe carboxylic acids vastayi. Anduke alcohol nu మనము మైల్డ్ కొంత స్లోగా ఆక్సిడైజ్ చేసి ఆపివేయాలంటే క్రోమిక్ యాసిడ్ ఈజ్ మోస్ట్ ఎసెన్షియల్. Okay, Jones reagent is not suitable for oxidizing acid sensitive substrates. So a number of chromic reagents have been developed in which Sarret's reagent, Collins reagent, ఇవన్నీ చాలా ఇంపార్టెంట్ అని అంటుంది. ఓకే, జోన్స్ రియేజెంట్. All chromium based reagents are most essential for the oxidation of alcohols into the either that is ketones or aldehydes. Sarratt's reagent, another one is Collins reagent are there. Sarratt's reagent. Okay, Sarratt's reagent is using pyridine in chromium trioxide. Okay, again it is converted into secondary alcohol is converted into ketone. Core's reagent. E.J. Core had developed many reagents. Okay, he had used 3,5-dimethyl pyrazole instead of pyridine. Okay, pyridinium PCC contains pyridinium chlorochromate. Instead of this one, he had used 3,5-dimethyl pyrazole. Anni edaina PCC aina, PDC aina, Core's reagent, Sarratt's reagent. Okay, it is nothing but PCC, pyridinium chromate. Pyridinium chlorochromate. Ikkada we are using pyrazole chlorochromate. Again, same product aithe same. Okay, it is called as Core's reagent. Pyridinium chlorochromate is using pyridine, and this reagent is yellow solid pyridinium chlorochromate called as PCC. Okay, it is soluble in all solvents. Okay, that is why it reacts with pyridine to form pyridinium chlorochromate. PCC oxidizes primary alcohols to aldehydes and secondary alcohols to ketones. PCC. Okay, it is converting primary alcohols. This is nothing but a secondary alcohol. Secondary alcohol is converted into ketone. Ketone laga ఏర్పడింది PCC reagent. మధ్యలో అంటే secondary carbon అంటే అందరికీ ఐడియా ఉంటుంది కదా. What is secondary carbon? Carbon bonded to two other carbons is called as secondary carbon. It is converted into ketones here. Primary carbon is converted into aldehydes. BPCC, bipyridine chlorochromate. Okay, 1,4-pyrazine, pyrazinium chlorochromate, Sarratt's reagent, even annam inta munde. Core's reagent are formed here. They are called as Sarratt's reagent. Another one name. Okay. Names are not in Core's reagent. Okay, they are also used for the same, converting primary into aldehydes and secondary alcohols into ketones. Okay, my dear student, try to understand how to convert alcohols into aldehydes, ketones, how thallium nitrate is useful. Okay, chromium oxide etla use avutundi ivanni మనం నేర్చుకోవాలి. PCC నుండి స్టార్ట్ అవుతున్నాం మొత్తం why we are using only chromyl chloride or chromic acid reagents? Because they will stop at the aldehyde stage, they will not go further. ముందుకు వెళ్ళవు అనమాట. ముందుకు వెళ్ళడం అంటే ఏంటిది? నెక్స్ట్ కార్బాక్సిలిక్ యాసిడ్ ని ఏర్పరచవు. బైపిరిడిన్ ఇస్ దేర్ హియర్, pyrazinium chlorochromate. PDC, pyridinium dichromate. Okay, it is nothing but DMSO. This reagent is quite soluble. Okay, it is prepared by using potassium dichromate. PDC veru, PCC veru. Okay, by using pyridinium dichromate, PDC also is very important reagent used for converting secondary alcohols. Okay, and primary alcohols aldehydes ఏర్పడతాయి, secondary alcohols అయితే ketones వస్తాయి. PDC, PCC, okay, BPCC లేదా PZCC ఇవన్నీ కూడా ఒకే type of reagents. Then DMSO itself is a reagent. It is a solvent, famous solvent, dimethyl sulfoxide, where ఏ కాంపౌండ్ అయినా ఎందులోనైనా కరగకుండా ఇందులో ఈజీగా కరుగుతుంది. ఎందులో కరుగుతుంది? DMSO. ఆర్గానిక్ తీసుకోండి, ఇన్ఆర్గానిక్ తీసుకోండి, అన్ని ఇందులో కరుగుతాయి. అంత ఫేమస్ సాల్వెంట్ ఇది. సల్ఫనైల్ సల్ఫర్, okay, is electrophilic in nature but is not sufficiently electrophilic. When sulfonyl sulfur ఇవన్నీ ఓకే చూడండి, మనకి ఏం కావాలంటే ఇక్కడ ఈ స్టేజ్ లో ఏం రియాక్టెంట్ తీసుకుంటున్నాము, ఏం ప్రొడక్ట్ రావాలంటే ఏ రియేజెంట్ వేయాలి, ఏ రియేజెంట్ ఏ ప్రొడక్ట్ వస్తుందో తెలుసుకుంటే చాలు. ఓకే, here what is done here is we are taking secondary alcohol, DMSO, dimethyl sulfoxide, ద్వారా ఏమొచ్చింది మనకు, we are converting into ketone. We are converting into ketone. Okay, that's most important. Dimethyl sulfoxide. Okay, dimethyl DMSO. DMSO, when the activator, it requires an activator, DCC, in the presence of H3PO4, known as Moffat-Fitzner oxidation. Okay, RL sulfur is activated by reagents dicyclocarbodiamide, DCC, otherwise called as DCC, in the presence of H3PO4. See here, this is called as DCC. Okay, dicyclocarbodiazide, diamide. Okay, DCC. DCC ని వాడుతున్నాం. వాడితే మనకు it is getting activated. Activate అయిపోయిన తర్వాత ఏమవుతుంది, hydrogen is shifted onto the sulfur. Sulfinyl sulfur is formed and it is finally giving ketone. Okay, just remember DMSO plus DCC. DCC structure into the dicyclohexyl carbodiamide. Imide, C double bond ಏನು ఉంటే imide అంటాం. Okay, that is an activator. In the presence of H3PO4 is also required. Okay, phosphoric acid is also required, H plus. Swarna oxidation. Okay, sulfonyl sulfur atom is activated with oxalyl chloride, DMSO, dimethyl sulfoxide ను ఇంతకుముందు మనము DCC తో యాక్టివేట్ చేసాం. Now we are using COCl taken twice, oxalyl chloride, oxalic acid. అంటే ఇది COH అంటే oxalic acid అంటాం. This is different, oxalyl chloride అంటాం. This is called as oxalyl chloride. Okay, it gives dimethyl sulfide. Dimethyl sulfide is formed. Okay, this one. Whereas the secondary alcohol is converted into ketone. Okay, what is Swarna oxidation? DMSO followed by oxalyl chloride, COCl taken twice. COOH taken twice into oxalic acid అంటాం. OH తీసేసి Cl పెట్టారు. It is called as Swarna oxidation. Fumarate rearrangement. In the case of by activated DMSO reagent, a common side reaction is this one. Methyl thioether is also formed. ఎందుకంటే ఇక్కడ మనం సెకండరీ ఆల్కహాల్ వాడుతున్నాం కదా, సెకండరీ ఆల్కహాల్ వచ్చి దీంతో రియాక్ట్ అయిపోయి డైమిథైల్ సల్ఫాక్సైడ్ తో రియాక్ట్ అయ్యి ఈ విధంగా ethers are formed. TPAP and DMP reagents. Recently used selective reagents, sensitive allyl alcohols ను ఆక్సిడైజ్ చేయడానికి వాడుతున్నారు. DMP మనం వాడినాం ఆల్రెడీ. Okay, for the oxidation of one of the alcohol, we had used this one. MnO2 is important. Simple reagents are very important, my dear students. What is the use of this manganese dioxide? A few more reagents still widely used. These are manganese dioxide and silver carbonate. Is mild chemoselective oxidation for allylic and benzylic alcohols. Allylic alcohol, allylic hydrogen is converted into ketone. Okay, allylic is converted into same selenium dioxide lagane ఇది. Allylic hydrogen ను ketone లాగా మార్చాలంటే selenium dioxide వాడొచ్చు లేదా manganese dioxide కూడా వాడొచ్చు. చాలా ఇంపార్టెంట్ రియేజెంట్ అనదర్. Okay, chemoselective primary and secondary allyl alcohols, no ionic intermediate is formed again. Okay, allylic alcohol is converted into ketone. It is also a reagent that is chemoselective oxidation of primary and secondary alcohols is converted into ketones, carboxyl compounds. Opanier oxidation, I think everybody knows about opanier oxidation, primary and secondary alcohols, chemoselective oxidation of them to aldehydes as well as ketones. What is required is aluminum isopropoxide, which is not strongly basic to promote aldolization of the product. It is reverse to the Merwin-Pondorf-Verley hydride transfer reduction. Okay, NPV reduction reverse anamata. Alcohols are converted into ketones. రివర్స్ వెళ్తే ఎంపీవి రిడక్షన్ అంటాం. అల్యూమినియం ఐసోప్రోపాక్సైడ్, ఓకే, ట్రై ఐసోప్రోపాక్సైడ్, aluminum isopropoxide is used where it is getting oxidized. It is called as open-air oxidation. Open-air oxidation is also used for converting secondary alcohols into ketones. The reverse of ketones into secondary alcohols is called as NPV reduction. Here is a 6-membered ring is formed as an intermediate. Okay, 6-membered ring is formed as an intermediate here. This is also very important reaction. Okay, 6-membered ring is formed as an intermediate in this reaction. Lead tetraacetate. Okay, lead tetraacetate is also used for converting alcohols into, okay, they are used to convert these alcohols into furan derivatives are formed. If there is a 5-membered ring, possibility is there, it is converted into a furan derivative. Lead tetraacetate is used like this. Not only this ones, diols, పక్కపక్కకే OH ఉన్నాయనుకోండి, అప్పుడు కూడా మనం lead tetraacetate వాడతాం తర్వాత. HiO4 lead tetraacetate. Okay, copper. Okay, that is by heating copper at 300 degrees centigrade. కాపర్ తో ఆల్కహాల్స్ హీట్ చేస్తే కూడా మనకు dehydrogenation takes place. Removal of hydrogen takes place and converting into ketone, like that. Primary and secondary alcohols can be dehydrogenated by this reaction. Hence catalyst. Platinum in the presence of oxygen is called as Hence catalyst. Platinum catalyst ఇది కూడా secondary alcohols convert into ketones here also. Lead tetraacetate and HiO4 మీరు ఇనే ఉంటారు. ఇది ఎక్కడైతే పక్కపక్కకి కార్బోహైడ్రేట్స్ లో అన్ని గ్లూకోజ్ స్ట్రక్చర్ చూస్తే OH లన్నీ పక్కపక్కకే ఉంటాయి కదా, వాటిని తీసేయాలంటే lead tetraacetate or పరయోడిక్ యాసిడ్. ఓకే, ఇక్కడ చూడండి OH లన్నీ తీసేయచ్చు, కట్ చేయొచ్చు మొత్తం. ఓకే, ఎన్ని OHలు ఉన్నాయో మనము వచ్చినటువంటి కార్బొనైల్ కాంపౌండ్స్, నెంబర్ ఆఫ్ మోల్స్ ఆఫ్ కార్బొనైల్ కాంపౌండ్స్ బట్టి ఎన్ని OH ఉన్నాయో చెప్పొచ్చు. ఓన్లీ the condition is that it should have OH group adjacently present. Okay, HiO4 తో కూడా చేయొచ్చు, పరయోడిక్ యాసిడ్ తో కూడా మనము చేయొచ్చు. Even in periodic acid also they are converted into C11O compounds. Very important, lead tetraacetate, HiO4, they are used to convert or degrade the carbohydrates, especially గ్లిజరాల్ ను మనం, ఓకే, OH ఇదేమో ఫార్మాల్డిహైడ్ అయిపోయింది, ఇదేమో ఫార్మాల్డిహైడ్, మధ్యలోది ఫార్మిక్ యాసిడ్ అయిపోయింది. ఏదైనా వాడండి, ఇది ఒకటి ఫార్మిక్ యాసిడ్, ఆల్డిహైడ్ ఏమో ఫార్మిక్ యాసిడ్ అయింది, ఇదేమో ఫార్మాల్డిహైడ్, ఇదేంటి గ్లైకాల్. ఓకే, దెన్ గ్లూకోజ్ మనకు తెలుసు. Okay, glucose, formic acid and formaldehyde are formed. ఇది ఒకటి ఫార్మిక్ యాసిడ్ వస్తుంది, CHO గ్రూప్, మిగతా అంతా formaldehyde is formed here. Okay, these are the oxidation with lead tetraacetate and pyrrolic acid. Salmlet oxidation. Okay, salmlet oxidation oxidize to aldehydes again of amines. Okay, ఇది దేనికంటే amines ను ఆక్సిడైజ్ చేయడానికి వాడతాం. Urotropin is used as a reagent here. Salmlet oxidation చాలా ఇంపార్టెంట్. ఇది కూడా salmlet oxidation, యూరోట్రోపిన్ వాడేటువంటి రియాక్షన్ ఏదయ్యా అంటే ఇదే మిథిలిన్ టెట్రామైన్, ఇది యూరోట్రోపిన్ అంటాం. ఓకే, ఈ యూరోట్రోపిన్ వాడి మనం ఏం చేస్తున్నాం, అమైన్స్, ఇప్పటి వరకు ఆల్కహాల్ చూసాం, ఇప్పుడు అమైన్స్ చూస్తున్నాం. అమైన్స్ ఆర్ కన్వర్టెడ్ ఇంటూ are oxidized to aldehydes direct గా degradation కట్ చేస్తున్నాం ఇక్కడ, and converting into CHO by using urotropin in the presence of an acid. Okay, formaldehyde 6 moles వస్తుంది, జస్ట్ గుర్తుంచుకోండి. యూరోట్రోపిన్ మన ప్రైమరీ అమైన్స్ are converted into aldehydes, that's all. తర్వాత మెల్లగా అర్థమవుతుంటుంది ఇదే. Okay, it is giving RCH2NH2, provides a method of oxidizing alkyl chlorides to aldehydes because reacts with hexamet in the presence of an aqueous acid to give primary amine. Okay, alkyl chloride తీసుకున్నా మనకు aldehydes వస్తాయంట యూరోట్రోపిన్ తో. ఓకే, ఎందుకంటే మనకు అమైన్స్ వస్తాయి, ఫస్ట్ అమైన్స్ మళ్ళీ ఇట్లా మారుతాయి. ఓకే, ఇక్కడ ఏం చెప్తున్నానంటే here urotropin is converted into amine in the presence of this compound. Okay, alkyl chloride is converted into alkyl amine in the presence of urotropin. This alkyl amine is converted into aldehyde easily. That reaction is very important. Somlet reduction, oxidation, somlet oxidation. Carose acid, H2SO5 is called as carose acid. Nitroso RNO is formed by the reaction. RNH2 unte RNO form aitadi, chivariki RNO2 is also formed. H2SO5 is called as carose acid. Okay, here also N oxides are formed. They are converted into, these are called as N oxides. They are called as N oxides, which are converted into nitroalkanes. They are converted into nitroalkanes. Alkyl halides oxidation. Amines lo somlet oxidation చూస్తాం. And another one is oxidation by using carose acid. Then alkyl halides are also converted into aldehydes by using DMSO, dimethyl sulfoxide, directly. Hexamethylene tetramine is also used. Okay, to convert them into aldehydes. This is about alkyl halides oxidation. Tollens reagent. What is the use of Tollens reagent? Only aldehydes will react with Tollens reagent to give silver mirror test. Here also aldehydes are converted into carboxylic acids. They are converted into carboxylic acids. Okay, silver mirror is formed. Silver is deposited. Why? Because it is completely reduced here. Silver plus is converted into silver. That is about Tollens reagent. Whereas Fehling's reagent also, what is going to happen is aldehyde is converted into carboxylic acid in Fehling's reagent. Okay, aldehydes convert into carboxylic acid. Direct topmost oxidized form of carbon is carboxylic acid. Chromic acid by hydride shift. Aldehydes are converted into carboxylic acid by hydride shift. Hydride H is shifted onto this carbon. Okay, first of all hydroxylation takes place, తర్వాత షిఫ్ట్ అయిపోతుంది. క్రోమిక్ యాసిడ్ వేస్తే ఆల్డిహైడ్స్ పైన వేస్తే అది కార్బాక్సిలిక్ యాసిడ్ ని ఏర్పరుస్తుంది. బేర్ విలిగర్ రియాక్షన్. Okay, what is going to form here? Carboxylic acids are converted into esters by using in the presence of peracids, peroxy acids. Okay, ketones are converted into esters. Sorry, Bayer vinegar oxidation, very famous reaction is. ఇక్కడ ఆక్సిజన్ వచ్చి చేరుతుంది మధ్యలో. జస్ట్ ప్రొడక్ట్ రాయాలంటే ఏం చేయాలంటే మనం ఆక్సిజన్ రాయాలి. ఇక్కడ ఆక్సిజన్ రాయాలి. మరి ఎక్కడ రాస్తాం అనేది క్వశ్చన్. ఏఆర్ సిఓఆర్ అయితే టెర్షరీ మిథైల్ ఇట్లా ఉన్నాయి అనుకోండి, ఇట్లా ఉన్నది. వాట్ ఈస్ వన్? టెర్షరీ బ్యూటైల్ ఆ టెర్షరీ ఆల్కైల్ అండ్ మిథైల్. ఇప్పుడు ఇది కీటోన్. బేర్ విలిగర్ ఆక్సిడేషన్ అంటే ఏంటిది? యూ హావ్ టు యూజ్ ఏ పెరాక్సీ అసిటిక్ యాసిడ్ ఆర్ పెరాక్సీ బెంజోయిక్ యాసిడ్ ఇస్ యూస్డ్. ఓకే, మెటాక్లోరోపెర్ MCPBA అట్లా వాడతాం. ఓకే, దెన్ ఇక్కడ ఆక్సిడేషన్ అయింది. వాట్ ఆఫ్ ఆక్సిడేషన్ ఇట్ ఈస్? పర్ యాసిడ్. ఇప్పుడు క్వశ్చన్ ఏంటంటే ఓ ఎక్కడ యాడ్ చేయాలి? ఇక్కడ యాడ్ చేస్తావా? ఓకే, వేర్ షుడ్ వి యాడ్ దిస్ ఓ? ఇక్కడ యాడ్ చేద్దామా, ఇక్కడ యాడ్ చేద్దామా అనేది ఎవరు డిసైడ్ చేస్తారు? మైగ్రేటరీ యాప్టిట్యూడ్. విచ్ ఈస్ గోయింగ్ టు గెట్ మైగ్రేట్? Tertiary is going to get migrated easily. Therefore, what we have to do is we have to use the oxygen at which end? This end only. ఎందుకంటే ఇది తొందరగా మైగ్రేట్ అవుతుంది. మెకానిజం చూడండి, మైగ్రేట్ కావాలి. ఇంకా ఇక్కడికి వచ్చి మైగ్రేట్ OH O తర్వాత R పైకి ఆక్సిజన్ పైకి మైగ్రేట్ అవుతుంది చూడండి ఇక్కడ. దిస్ ఈస్ గెటింగ్ మైగ్రేటెడ్. Okay, one of the alkyl group is getting migrated onto this oxygen bonded to our carbonyl group. ఇది బాండ్ అవుతుంది. బాండ్ అయిన తర్వాత మైగ్రేట్ అవుతుంది. మైగ్రేటరీ యాటిట్యూడ్ ఇట్లుంటుంది. చాలా ఇంపార్టెంట్ ఆర్డర్ ఇది. ఇది అన్ని రీఅరేంజ్మెంట్స్ కూడా వర్తిస్తుంది. బెక్మెన్ రీఅరేంజ్మెంట్ లో కూడా సేమ్ ఆర్డర్. బేయర్ విలిగర్ రీఅరేంజ్మెంట్ లో కూడా సేమ్ ఆర్డర్ ఉంటుంది. ఓకే, దట్ ఈస్ అబౌట్ అంటే కాంపిటీషన్ వచ్చినప్పుడు బెక్మెన్ రీఅరేంజ్మెంట్ లో కూడా సేమ్ ఉంటుంది అని అనుకుంటున్నాను. ఓకే, migratory aptitude, that is about oxidative rearrangement of amines to amides. Ketoximes are getting rearranged to form amides. Ketones convert into oximes, which are converted into amide. Okay, NBS, N-bromosuccinamide. What is the use of this NBS in the presence of triethylamine? Allylic bromination. Allylic ante double bond undali, pakkaki idi undali, NBS. And triethylamine will remove this one and it is forming alpha beta unsaturated ketones. Okay, alpha beta unsaturated ketones are formed. Omega keto carboxylic acids, KMNO4 directly will break this bond. Okay, break this bond at which position? పొటాషియం పర్మాంగనేట్ డైరెక్ట్ గా ఇక్కడ బ్రేక్ అవుతుంది. ఈ C double bond O వస్తుంది. ఇట్ ఈస్ కాల్డ్ యాజ్ ఒమేగా కార్బాక్సిలిక్ యాసిడ్. ఓకే, ఒమేగా కార్బాక్సిలిక్ యాసిడ్ ఈస్ ఫార్మ్ లైక్ దిస్. ఆల్ఫా ఒమేగా పరాయోడిక్ యాసిడ్ ఇంతకుముందే మనం నేర్చుకున్నాం. HiO4 ఉంటే రెండు పక్కకు డబుల్ బాండ్ లో ఉన్న కట్ చేస్తుంది. Okay, selenium dioxide, we know that it is going to form, and less regioselectively and stereoselectively this hydroxylation or double bond O వస్తుంది. Then ఇవన్నీ కొన్ని రియాక్షన్స్ ఇది చూడండి. హైడ్రాక్సీ యాసిడ్స్ ఆక్సిడేటివ్ డీకార్బాక్సిలేషన్ ఆఫ్ హైడ్రాక్సీ కార్బాక్సిలిక్ యాసిడ్. డీకార్బాక్సిలేషన్ చేయాలి. లెడ్ టెట్రాఎస్టేట్ వాడి డీకార్బాక్సిలేట్ చేసి ఆల్డిహైడ్లుగా మార్చేయచ్చు. ఓకే, ఎప్పుడైనా పక్క OH రెండు ఉన్నప్పుడు రెండే రియేజెంట్స్ వాడుతున్నాం, లెడ్ టెట్రాఎస్టేట్ లేదా పరాయోడిక్ యాసిడ్. OH ఉంటే లెడ్ టెట్రాఎస్టేట్, డబుల్ బాండ్ ఓవల్ ఉంటే ఎక్కువ మనం పరాయోడిక్ యాసిడ్ కూడా వాడచ్చు. ఓకే, థ్యాంక్ యూ స్టూడెంట్స్. దట్ ఈస్ అబౌట్ దిస్ oxidizing agents. I will share the PPT also. In the next class we will see about reductions, reducing agents gurinchi మనం నెక్స్ట్ క్లాస్ లో చూద్దాం. ఎనీ డౌట్స్? ఉన్నాయా? థ్యాంక్ యూ. అర్థమైనా? ఏమన్నా అర్థమైతేనే, ఎందుకంటే సింపుల్ రియేజెంట్స్ ఇంపార్టెంట్. Okay, somebody wants to ask a question. I will allow you to unmute. మాట్లాడొచ్చు.
సార్ మెకానిజం కంప్లీట్ అయిందా? ఇంకో చెప్పండి.